Okay. Get your notebooks out. And keep reminding me if you can't see, I have to tilt my screen because I'm kind of using the whole board. I think we're good to start with here.
All right.
Okay, so we've done section 1, and that was general sequences and series, just to give you the idea of the notation for a sequence and the sigma notation for a series, learning how to work with those things. Now in sections 2 and 3, we do very specific ones. In section 2 here, we do what is called an arithmetic sequence and series. Analyze arithmetic sequences and series. And in section 3, we do what is called a geometric sequence and series. And in both cases, there are formulas. There's formulas for the sequences, and there are formulas for the series. In section 1, like if you wanted to find the sum of a series, you had to actually generate all the numbers and add them up. Well, you're not going to have to do that now with the series. There's going to be a formula you plug into the formula, and it'll give you the sum of the series. And as far as the sequences go, in section 1, you had to hope you could see the pattern to be able to find the rule. Well, now finding a term generator for one of these arithmetic sequences, there's a formula you plug into, and it'll give you the rule. So both problems are easy now, where we are actually given the term generator, and you just plug in the natural numbers and generate the sequence. That's always easy. But the tougher one was when you were given the sequence and you had to find the rule. Now you're going to see we're going to be able to do that. All right, so we're going to start out here with an arithmetic sequence has a common difference, which we call D. Between the terms, there's a common difference. If you were to take the first term and add that to the first, you'd get the second. Add it to the second, you'd get the third, all the way down the line. The thing that's called the common difference. So if you just subtract any two terms, you get the same number. All right, now in general, this is what an arithmetic sequence would look like. The first term we call a sub 1. The second term now, instead of using a sub 2, we know it would be the first term plus that common difference D. So it would be a sub 1 plus D. And the next term, you would add D to the second to get the third. And that would be a sub 1 plus 2D. And then add D and get a sub 1 plus 3D. And you would continue doing that. What we need to do is come up with a formula for the nth term. Let's take a look at what we have here. They all start with a sub 1. And so this is going to be a sub 1 plus. Now, what's the connection between the n and the d? Here you get a sub 1 plus 1d, and it's the second term. Here it's a sub 1 plus 2d, and it's the third term. So what's the connection between the D and the numbered term?
It's n minus 1 times D.
All right, it's one less, isn't it? So that would be n minus 1. And so what you get is a sub 1 plus n minus 1 D. And that is the formula. A sub n equals a sub 1 plus n minus 1 times D. That's the formula for an arithmetic sequence. And so if you had to find the term generator for an arithmetic sequence, you need to find a sub 1, the first term of the sequence, and D, the common difference. The n is going to remain n. That gives you the formula in terms of n. So you need a sub 1 and D. All right, well, let's do some of those problems we did in section 1, where you're given the sequence and you had to find the term generator. You had to find the rule. So write a rule here, 4, 9, 14, 19. So what do we need for finding a sub n? We need a sub 1 and D. In this problem, what's a sub 1? 4. So you're going to get a sub n equals 4 plus n minus 1 times D. What's D? What is the common difference?
5.
5. I'm going to put it in front. Instead of n minus 1 D, I'm going to put the D in front. And so then all you really need to do is simplify this. And you end up with 5n minus 5 plus 4. So that's the rule 5n minus 1. That's your a sub n. There's your term generator. And so again, imagine if you just saw these numbers and didn't know anything about arithmetic, and you were trying to generate that rule. That would be very difficult. But now that we know it's arithmetic and it has a common difference and we know the formula, it's real simple to come up with the rule. You just find your a sub 1 and your D and plug it into the formula. And so we'll do one more here real quickly. What's B sub n here? A sub 1 plus n minus 1D, right? So what is it? It's 60 plus what? What's D?
12 or
8.
Not 8.
-8.
Negative 8. So it's 60 plus, so we'll say instead of plus, it's minus 8 times n minus 1. And so you get minus 8n plus 68 if you simplify that. And there's your rule. So section 1, the tougher problem, given the sequence, find the rule. Now it's an easy problem. It's real easy to find the rule of an arithmetic sequence. You just need to know this formula. Okay, now there are 2 other type of problems we're going to do with arithmetic sequences. The first one, can we see this?
Yes.
Okay, write a rule given a term and the value for D. So we're being given a term. Here we're given a sub 19 is 48. And we're given D is 3. And from that information, you need to come up with the formula for a sub n. Well, to find an a sub n, you need a1 and D. You have D. So all you really need to do here is find a sub 1. And so all you have to do is take the given term and write this out. What do we know about a sub 19? A sub 19 happens to be 48. And that equals a sub 1 plus n minus 1, which is 18 times d, which is 3. And so by using a sub 19 as 48, you get this equation. 48 equals a sub 1 plus 54. And from that, we can find a sub 1. It's 48 minus 54, which is what?
-6.
-6. And now that we have a sub 1 and we have d, what is a sub n? It's a sub 1, -6, plus n minus 1 times d. So plus 3 times n minus 1, which would be a sub n equals 3n minus 9. And that's it. So if you're given a single term and you're given d, you can find the term generator because you can find a sub 1. You take the given term and you use the formula and you're able to find your a sub 1. All right? So write this one down as a problem to put in your notebook. If you were given a sub 11 to be -57 and you were given d to equal -7, do that later. Put that in your notebook and do it after we're done as an example of this type of problem. You should be able to do that problem. All right? So that's the second type of problem. First is finding the term generator from the sequence. Now it's finding the term generator from a term and d. Okay, now the last problems here. Let's see if we can see these all right. Okay, now we want to write a rule given two terms. You're being given two terms. Here we're given a sub 8 is 21 and a sub 27 is 97. Given two terms, can you find the term generator? And what's it take to find the term generator? You need a sub 1 and d, right? So somehow from this information, we need to find a sub 1 and d. Well, it turns out we can, if you understand how an arithmetic sequence works, we can easily find the d to start with. Now, the book actually doesn't do it this way. The book uses these two terms and comes up with two equations in two variables and makes you solve a system to find a sub 1 and d. They get two equations in a1 and d, and then you solve a system. But here's an easier way to do it. If you knew the 27th term was 97 and the 8th term was 21, then the distance from 97 to 21 covers how many D's, how many gaps. Well, 27 minus 8 is 19. There would be 19 equal gaps covering a distance of 97 minus 21. So you simply subtract the two values, get 76, put it over the subtraction of 27 and 8, 19, and you get the fact that D must be 4. That's the easy way to find D. Subtract the terms over the number of terms, and you can find D. And now let's think about it. We have D now, and we have two terms, and up here all we needed was one term and D. So take one of these terms and take your D and do what you did up here. So I'm going to take A sub 8 is 21. And I'm going to use D equals 4. And we're going to be able to find our A sub 1. So the A sub 8 is 21. A sub 8 is A sub 1 plus N minus 1 is 7 times D, which is 4. And A sub 8 is 21. So 21 is A sub 1 plus 28. So the A sub 1 must be negative 7. And now you've got A sub 1 and you have D. D is 4. And so A sub N must be A sub 1 negative 7 plus N minus 1D plus 4 times N minus 1. And now you've got your term generator. It would be 4N minus 11 if you simplified it. So given two terms, you can find the term generator by first finding D and then using a term with D, which is what we did up here. And that gives you your formula. Okay? In your notebook, write this problem out. Give yourself A sub 7 to be 26 and give yourself A sub 16 to be 71. And you then, after we're done, find A sub N from that information. From the notes you took, you should be able to figure out how to find your A sub N. What would be the first step here? Finding what?
D.
D. And what would D be?
5.
71 minus
26.
26 over what?
16 minus 7.
16 minus 7. And then you'd have D, and then you could take either one of these two terms with D, and then you would do what you did up here, and you would find your A sub N. All right? Are we good? Any questions on this? This is arithmetic sequences. What you have to know. How to find your A sub N formula, given different information, given the entire sequence, given a term and D, or given two terms. Okay, that takes care of sequences. Now let's look at series. See if we have this up here. Okay. The sum of the terms of an arithmetic sequence is an arithmetic series. That's what an arithmetic series is, adding up the terms of an arithmetic sequence. Now, we're going to generate a formula for finding the sum of an arithmetic series so that we don't have to generate all the terms and add them up. There will be a formula you plug into and it'll give you the sum of the arithmetic series. And here's how we generate it. We have to be a little clever here. First thing we're going to write is what is called S sub n, capital S sub n. That's your A sub 1 plus A sub 2 plus dot, dot, dot to A sub n. That's the sum of the terms of the sequence. Makes up S sub n. Only we're going to write it like this. We're going to say it's A sub 1 plus your second term, we're going to write as A sub 1 plus D. We know that to be A sub 2. Your third term is A sub 1 plus 2D. And then you keep doing that all the way down, but for the last term, we're not going to write A sub 1 plus n minus 1D. We're going to write A sub n. So here is S sub n, adding up the n terms of the arithmetic sequence. And then we get clever. We write S sub n again, only this time we reverse this thing. And we start with A sub n as our first term here. We take the last term and write it first. And then we realize the next term after this one would be D less than A sub n. So we write it as A sub n minus D. Then you get A sub n minus 2D, all the way down to the last term, which is your A sub 1. So you'll see it's just being very clever how we're writing this to establish this formula. We're just writing S sub n in two different ways. And now we're going to add these two up. And that would give you 2 S sub n. And what would it give us? It would give us A1 plus A sub n plus A1 plus D plus A sub n minus D. And that gives you A sub 1 plus A sub n. And then A sub 1 plus 2D with A sub n minus 2D. And that gives you A sub 1 plus A sub n. And you keep going like this, plus 3D and minus 3D. You get another A sub 1 plus A sub n, all the way down the line. The last one would be A sub 1 plus A sub n. And so now 2 S sub n's equals the sum of these A1 plus A sub n. How many of these do we have? If you're going from A1 to AN. How many of these A1 plus A sub n's do we have? Anybody?
Be infinite or no?
No. We start with A sub 1 and we go to A sub n. So
Oh.
how many do we have?
N minus 1?
Not n minus 1. 1 plus 2 plus 3 plus dot 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 plus n. We have n of them. There are n of these terms. So we must have n of these A1 plus A sub n's. So when you add these up, you get n times A1 plus A sub n. And that's what's equal to 2 S sub n. So your S sub n must be n over 2 times a sub 1 plus a sub n. And that's the formula for the sum of an arithmetic series. Your S sub n equals n over 2 times your first term, a sub 1, plus your last term, a sub n. Now the book writes it and puts the 2 over here. Same thing. It says n times a1 plus a sub n over 2. So you could put the 2 under here or under here, either way. This is just the way I'm used to it. But like I said, the book puts it under a1 plus an. And that's really the average then of those terms, a1 plus an over 2. But this is the formula for the sum of the first n terms of an arithmetic series. So you need to know your n, how many terms you're adding up. You need to know your first term and your last term. And you can get the formula. So here we go. Find sigma I equals 1 to 20 of 3 plus 5i. If this is a linear formula, this is an arithmetic series. Linear formulas give you an arithmetic sequence. So this is an arithmetic series. And so what we need to find is S sub 20. We know we have 20 terms here. So what is S sub 20? It would be what? 20 over 2 times what? A sub 1. What is A sub 1? This is the A sub n formula. So what's A sub 1?
8.
8 plus your A sub n is 20. So you want A sub 20. What is A sub 20?
$103.
103. And so you end up with 111 times 10, which is 1110. And so in section 1, if I asked you to do this problem, you would have had to let I go from 1 to 20 and produce every number and then add them all up. But now that we know this is an arithmetic series, you just plug it into this formula. It's the n over 2 times the first term plus the last term. So you need to know your A sub 1 and your A sub n and your n to use the formula. All right? Let's do one more. Find sigma I equals 1 to 12 of 2 plus 7i. So I equals 1 to 12, that's S sub 12. So what is S sub 12 going to equal? N over 2, 12 over 2 times A sub 1. What is A sub 1?
Mr. A, can you move it down a little?
What is A sub 1 here?
9.
9 plus A sub n is 12. So A sub 12. 2 plus 7 times 12. What is
86.
that? What's 7 times 12? 84 plus 2, 86. And so you end up with 95 times 6, whatever that is. And that's how you use the formula for an arithmetic series. You need n, you need a sub 1, and you need a sub n. And when you're given sigma notation, there's your n, and your a sub 1 is putting a 1 into this, and your a sub n is putting the n into that. And you get the numbers you need.
Mr. A, is A sub n the last term of the sequence? Is that
Yep.
okay?
So that would be a sub 12 is what you're looking for. So you put a 12 for I. And this generates the terms of the sequence that you're adding up.
So what does the n stand for?
It's how many terms you have.
Okay, all right.
And you need the n for the n over 2. And then you need a sub 1 and the a sub n.
Okay.
And then you've got your formula. Okay, now this next one is a little different. This time, we want the sum from I equals 4 to 10. S sub n is a sub 1 through a sub 10. S sub 10 would be a sub 1 through a sub 10. We want I equals 4 to 10. So there's two ways to do this problem. One way is using your S notation. It would be S sub 10, which would be I equals 1 to 10 minus what? What would 4 to 10 be? Going from 1 to 10 minus what? Going from 1 to
4,
not 4.
6.
What are you doing, 6? Which ones are you missing? 1, 2, and 3. You're adding from n equals 4 to 10. I equals 4 to 10. You're going from the 4th term to the 10th term. You're missing the 1st, 2nd, and 3rd term. So if you want to add from the 4th to the 10th, add from the 1st to the 10th, which is what S sub 10 is. That's going from the 1st to the 10th minus S sub 3, going from the 1st to the 3rd, adding 1, 2, and 3. A sub 1 plus A sub 2 plus A sub 3. Subtract that off, and you get the 4th through the 10th. Do you see that? And so then you would compute S sub 10 as n over 2, 10 over 2, your A sub 1. Now your A sub 1 is letting I be a 1, and you would get 5 plus your A sub 10, which would be 32. And that would be your S sub 10 minus your S sub 3. Your S sub 3 is 3 over 2 times your A sub 1, which is 5, plus your A sub 3, which is 11. And that would be the answer. You would compute this and compute that and subtract the 2. Do you see this? The sum from the 4th through the 10th is the 1st through the 10th minus the 1st to the 3rd. You would be left with the 4th through the 10th. Okay? Then you can use your S sub n formula. Now, there's actually another way to do this problem where you treat I equals 4 as your first term. You write it using this notation here. And so you would let I equal 4 and get 12 plus 2 is 14. And you would have 14 plus, then I equals 5 would be 17 plus dot, 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 plus I equals 10 would be 32. You would be adding from 14 to 32. And now how can you use S sub n to add from 14 to 32? Now you treat this thing as the first term. You treat 14 as your A sub 1. How many terms would there be? Well, the I equals 4 is becoming your first term. So that's 3 less. So your 10 would be your 3 less 7th term. There would be 7 values here. And so you would be computing S sub 7 as 7 over 2 times A sub 1 is 14 plus your A sub 7 is 32. And that's the other way to do this problem here. Treat your fourth term as the first term. Put a 4 in and take that number as your first term. Put a 10 in and it becomes your 3 less, your 7th term. And you're adding these 7 numbers up. So you would get 7 over 2 times your A sub 1 plus A sub 7. So those are the 2 ways to do that problem. And now that I've done that one there, let's do this one here. Can we see it? If I just gave you, instead of sigma notation, if I just gave you a sum of numbers like this, how could we use S notation? Well, you know your first term and you know your nth term, right? What don't you know?
Rule.
For this formula, what do you need? You need n, don't you? We don't know n. So what we would do is look at this as a sequence of numbers, an arithmetic sequence, and we would find our n. Because we would generate our A sub n equals A sub 1 plus n minus 1 times d. D is 4. So you get 4n minus 4 plus 2 is minus 2. You would take 4n minus 2, set it equal to 58, and 4n would equal 60, and n would equal 15. So we would have 15 numbers here. So you would be computing S sub 15. And that would be 15 over 2 times your A sub 1, which is 2, plus your A sub 15, which is 58. And you would get that answer. So you have to know how to use the S sub n notation when you're given a series of numbers. And you need to find the A sub n formula for those numbers so you can find the n. We need to know how many numbers we're adding up. We need n. Look at the formula. You need n, you need A sub 1, and you need A sub n. First and last term, and you need to know how many terms. And that's what you would compute given the notation like this, as opposed given sigma notation. Or if you want, you could take this and write it in sigma notation. You do the same work to write it in sigma notation. Okay? Any questions on series? I think it's just a matter of getting into it and doing the homework and getting some repetition. And then you'll come to really know your formulas. So you have your A sub n is A1 plus n minus 1D, and you have your S sub n is n over 2A1 plus A sub n. Arithmetic sequence, arithmetic series. All right? Are we good? We're good. All right, now let's see what we're doing here. We have homework tonight from section 2 from the book. And then Monday, you have a quiz on 12.1. And there is no session on Monday. We do not meet on Monday. Monday's homework is more work from section 2 here, arithmetic sequences. On Tuesday, it's another book assignment on arithmetic series. On Wednesday, it's delta math assignment on arithmetic series and an arithmetic series. Now, Wednesday next week, we're going to meet and we're going to do geometric sequences in series. And then that'll take you through the rest of the week so we don't meet on Friday. So next week, we only meet on Wednesday. All right? That makes sense?